Good afternoon. My name is Dipal. I am a principal engineer at Dream11. I have also the ownership from Dream11. Today we are going to talk about Aerospike Beyond Cache. Slight history about the Aerospike at Dream11. We started using Aerospike somewhere in 2018. That time the primary use case for the Aerospike was using as a caching layer. But then in 2020 we managed we moved for the managed services. Then we started using it for a strong consistency mode because some of the operation with the scaling and downscaling activity was trickier for the strong consistency. Hence we took that managed service. But still at Dream11 for the self-managed services, we were largely using using the Aerospike for the caching layer. But then we started expanding our footprint to Aerospike and started exploring Aerospike beyond cache. And today we are going to talk about the same thing, that how we are leveraging Aerospike in few of the services as a primary database. But before that, a few points on the Dream11 is the world's largest fantasy sports platform. We have more than 190 million registered users. Our peak concurrency is more than 10 million, and this IPO hit the peak concurrency to be 10.56. On a daily basis, we are ingesting 35 terabyte of data. Our peak edge R3 is 308 million. We have 12 different sports hosted on our platform, including cricket, and we are hosting more than 12,000 matches on an annual basis. Just all the details to the typical life cycle of a match on the Dream11 app. So generally a match is open for the user to join roughly 2 days before the start time, but we get majority of our traffic in the last 30 minutes of the match, as you can see. And after match starts, user cannot join the match, and that is why our business is very time sensitive. Hence, we need very high availability in the last 30 minutes. And as you can see that most of our user traffic is, we get most of our user traffic in the last 30 minutes. All our system is get the maximum RPM, and we need to be highly available. We need to serve those within the defined SLAs. Once the match is started, we serve the leaderboard, and which gets refreshed from time to time. Once the match ends, we declare the winner. So as we can see in the first screenshot, that is where we list all the different matches. I have taken the example of one of the sports and just click it here. And then to play any of the match, you need to create a team, and that is what the second screenshot shows. And the third screenshot, you can see that in between the various contests that is hosted within a match. We have like mega contest, small contest, the private contest, all different varieties of contest. The mega contest has the biggest prize too. And once you are sure about the particular contest, then you join a contest, and that is what we can see in the last screenshot. Once we join a match, we can see at two different places on the app. One is the one in the browser mode, which is a concise view of the joined matches, which is either in the upcoming live or completed. And the other is like you can click on one of the icon, my matches icon, which is present at the bottom of the screen, and in which there are 3 different tabs. So once you join a match, it will come in the upcoming tab. Once the match moves into the live mode, match is started, it moves into the live mode. Once the match is completed, you can see all your matches that you have played in the completed tab. So today, like we are going to talk about the My Matches service, that how we leverage Aerospike. It's like a story on like what happened in 2022 IPL. We started seeing some performance issues in this service, which was hosting this PZO service for us, which was like powering all the different matches that the users played, and which is in multiple modes. And then once this, then we started to, then we thought of like revamping the service. But before talking about how we are leveraging Aerospike in this, let's talk about what was the old architecture. That is the right before Aerospike. So what were the problems that we were facing in this particular architecture? We were using 2 database components, which was Amazon RDS, which was for persistence layer, and Redis for caching layer. This service was like multiple data source was ingesting the data in this particular service because the service like team service or a leaderboard service or a content service which was feeding the different kinds of data which was required to power the respective screens on the My Matches. The few of the limitations that we are seeing here, the first thing was the scalability, as RDS Aurora is a horizontal scalable versus vertical scale. RDS Aurora is a vertical scalable database versus the horizontal which was required. And beyond a point, you cannot scale one node of our RDS Aurora. Then, as we were getting more and more users and more volumes of data, we were facing issues with the pagination query, which was effectively scan query in case of RDS Aurora. That is when we were facing another sort of limitation. With the large volume of the data, we thought of archiving the data from time to time because we wanted to show for the last X period of time, and that is that the archival management was very important. And with the RDS Aurora, we needed to perform that activity from time to time, and that was an inadequate archival management was another bottleneck that we were facing. With the RDS Aurora, with the high write TPS, your read TPS also goes low, and since this service has quite high RPM, so our read TPS used to be a bottleneck because we were writing at the same very high volume at the same time, and that is another limitation that we were facing. And with the entire thing, as we were scaling up our system vertically in case of RDS Aurora, and with the using of elastic cache, we were facing the high infrastructure cost on the scale.
And the reasons so
the few things to when we have decided to revamp our architecture, the few things that we wanted to keep in mind was the system should be horizontally scalable. It should support high write TPS with the big TPS with the tunable consistency in our scenario, and it should if it supports some kind of auto archival which can say that the TTL at a record level, and with everything the infrastructure footprint should be low. So before moving into a re-architecture, the simple solution could have been replacing the RDS Aurora with a NoSQL database, but we thought further and went on the whiteboard to think that can we replace both RDS Aurora and elastic cache to one component, because that will effectively reduce our one failure mode, and which will give us a highly available system, a better highly available system compared to a two component where the failure mode increases. And that is where we did a POC of Aerospike with a persistence namespace and see whether it meets our SLA or not, and it proved to be right and met our standards in the POC phase, and hence we thought of using Aerospike in the Aerospike for elastic cache and RDS Aurora in our case. And to make it highly available, we decided to have a passive Aerospike cluster as well with XDR enabled. And in this Aerospike cluster, what we decided to keep it was for any dynamic data, we decided to have a in-memory namespace, and that was for upcoming and live that we saw in the previous screenshot. For the upcoming and live tab, we went ahead with the in-memory namespace, but for the completed, which is a static data, we do not change. We decided to go with the persistent namespace. And for the static data, we were pushing the data into the My Matches cluster using the Amazon S3 and the Spark Apache Spark. And if we talk about the new architecture, we got the high availability, and want to touch upon the smart pagination. One of the issues that we faced in our limitation was the pagination scan query that we were able to achieve using the two Aerospike operation. In the first operation, we maintain the user data, which is called the shard meta information, And in this case, we decided to go with the month granularity upon the analysis of the data, that okay, if in one key, what is the amount of data that we'll be having in the worst case scenario, and we decided to go with the month granularity, and that is what we are storing in the shard meta, that at a month level, like how many matches that a user is joining. And then once we have this shard meta, that is a single get query. Once we have this information, depending on the page number, we figure out that what are the set of keys that we need to fetch it from the Aerospike, and then we do a multi-get query, which is quite efficient in Aerospike, and then we are able to fetch all the relevant information for that user from the Aerospike. So this is effectively a two Aerospike operation in which we are able to serve the pagination queries, and which is highly effective, and it is scalable no matter what, for how many years that we want to keep the data in Aerospike. And then with everything, we have got the reduced infrastructure, because we have removed one of the component. We have effectively removed the persistence and the caching layer with Aerospike here, and that gives us a less failure mode. That is one less failure mode for our use case. And then we are also getting an auto archival feature that we used to manage previously with the RDS Aurora. Now we can use a TTL at a record level, which gives us archival from time to time, basically without any manual intervention. This is the performance number, and this is the data from the IPL final, IPL 2023 final, where like we were able to serve 500,000 read with the 50k write TPS and the 500,000 read TPS within a P99 of 1 ms from the Aerospike cluster, and the infrastructure which was used for it was 21 node R5DN2X large machine. And in the passive mode of Aerospike as well, we kept the same number of node, although we can downsize the passive cluster to a lesser infra, because that is used for the failure mode rather than for any active use case. And the CPU for the active Aerospike went up to maximum 25%, and for the passive Aerospike it went up to 10% because of the replications. Now over to Atul to take you through the chaos engine and some other use case of Aerospike at Dream11 to make sure, like how we make sure that our system is highly available.
Yeah. So thanks, Vipul. Yeah, I'm audible, right? So one more very good use case we have is the team service. Like if you have played fantasy gaming, everyone has to create a team, and that team has to be consistent. Like whatever you write, you have to see it. Okay, and the scale is also enormous. So this is just a very high level overview of our team service. Okay, we have an application written in Vertex. We have primary database Aerospike, and we also get it replicated into the passive Aerospike. Okay, so the thing is, like, the scale is so high, and team service is so critical to our business. Like the whole business of Dream11 is on team service and context join. We cannot afford a minute of downtime. So anytime if you want, like if something goes wrong, maybe Aerospike, maybe application, we should be able to switch to the other system. So this, we have a one-click switch architecture. Okay, what it does is we have a dual write, like the application writes to both the databases, the active one and the passive one, and also it is getting synchronized by a consumer. So this is a very, very high level of team service architecture. And as I said, like team service is like super critical to fantasy gaming. Like let's say during a IPL game, like we get a team creation request of around 65k TPS or 0.5 million writes per second. Okay, and we cannot afford a single 1 minute of downtime. 1 minute of downtime is also $1 million of revenue loss. Okay, so that is why we need a very robust database, and that is why we have to do a lot of chaos testing. Imagine, like you have, if you compare it to Swiggy or if you compare it to Zomato, imagine like all the users of these companies are ordering food in 1 minute. That is the amount of scale we have in team service, and why it is important to have to be robust. So these are some stats about team service, like 0.5 million writes per second, 1.3 million reads per second, okay, and a burst from 7k to 65k in 5 seconds. This is the scale what we have. And also this in a strong consistent mode, like all the reads are linearized read. So basically linearized read is, you get the data from the master, also you consult the readers also for the regime. Okay. So so that is why we need a lot of chaos testing, and these are the flows which we tested, like a single node failure, multiple node failure, RF number of nodes going down at a time, more than RF number of nodes going down at a time, because the cluster behaves differently during these modes. Okay. And so even we simulated a complete AZ down failure, and what we wanted to achieve is that whenever there is any outage, like maybe Aerospike is down, but when it comes back, when it is stable, like there is no delay, or the cluster is stable within seconds, and the application also stable in within seconds. So how fast do we recover from this? This is what we wanted to test, and this is how we achieved it through all these test cases. Okay, if you see the graph, like there is this is a one zone down failure, and just a glitch of there is a glitch over here that the latencies have shooted and the error rate has increased, but like within the next second it has gone down. So this is like very good for us. So even we did a mock split brain test out here. Like basically what we do is like we block the traffic from the subnets. So you just change the IP tables and you drop some packets, or drop some traffic from one of the subnet, inbound traffic and outbound traffic, with which you can simulate a split brain. This is the behavior of a split brain. Like if you see, once the split brain started, like few partitions become unavailable, and once you are recovered from the split brain, like the cluster has recovered fast. So of course, like there is, if you go to Azure, GCP, AWS, there is always going to be network latencies. Some small network latencies can transmit into huge network latencies, like because of linearized read. In linearized read, you need to consult to all the replicas. So it is very crucial for us to test that your system behaves correctly in case of there are network glitches. So we just inject, there are basic commands with which we inject some latency into the network and see how it behaves. So we are ready with all the operator actions what you have to take. Okay, you can even use AWS systems, like most of our infra is on AWS. We use AWS FIS to inject network congestions, okay, and simulate these things. Also, like in the last year, like there were some outages in EBS, and that cascaded, and there were a lot of outages in our services. So we also started testing EBS outages. Okay, EBS failures, like you can make your volume read only, or you can have a AWS service also is there, which pauses the ABS volume IO. Okay, and other test cases are also there, like you disable the port and you stop the traffic and you simulate split brain and you see how your system behaves and how quickly you can come back from it. This is what all we wanted to achieve, and we have written scripts and a lot of exhaustive test cases been covered out here in this section. Yeah, that's it, guys.
Any questions?
Hey, it was a good presentation. Yeah, as the government has come with new rules this last quarter, so what are the tech changes Dream11 is planning, and how Aerospike use can be like, what different use case like Aerospike you are planning for the cost optimization?
Yeah, like again, like I cannot tell you the business implications, but of course, like from Aerospike perspective, like we are moving to Graviton instances, like Aerospike 6.3 onwards supports Graviton. So we have moved all our clusters to Graviton, and that has significantly reduced, the footprint, infra footprint, like, and also like Graviton instances are way superior. Like we got a 20% increase in performance. So this overall reduced our infra cost, and the performance also very high. So both in memory and like persistent storage, we could get that benefit.
We are trying to move away from the persistence layer in like RDS Aurora or some other database, and persistence plus caching layer to a single data source which can give us the same kind of latency in our read and write traffic. So that is where like we can improve on our infra cost. At the top, like Graviton instances are performing better for us as well.
Thanks.
Thank you for the great presentation, guys, first of all. But here. I- So I just have one concern. Since you're using this as a primary database, so there will definitely be a lot of concurrent requests, read and write requests on a certain key record. So did you come across any hotkey issues, and
Yes.
how did you handle that?
So we are trying to batch our query at an instance level for the same key. So like since our RPM is quite high, so we do face such kind of issues, and that is where like we have optimized that. Okay, if we are getting the request for the same kind of key, so only one request goes to the database and rest all waits, and once it is fetched the data from the database, so all will give back the same response.
You're doing that on the consumer?
No, at the machine level,
Okay.
at the application level.
All right.
So whatever, like we are using a Vertex Java here, as you have seen. So we do that at our application layer.
Okay, so the Kafka sends the entire event of
So
the...
Kafka is feeding the data
Right, yes.
which is required to power your screens. But a web application is different, which is like the Vertex plus Java. And that is where like we batch our request depending on the kind of request. And if it is for the same key, so we do not allow all the requests to go to the database, only one request go to the database.
Okay, thank
So
you.
also in Aerospike, we use randomized read after the matches, like after the match starts, like that time once the match starts, you cannot edit the data. Okay, that time we use a much lesser consistency level.
With tunable consistency that we tune depending on the scenario.
Okay, thank you.
I have a question.
My name is Krishna. Could you just show the slide of your old architecture versus the new one? I
Sure.
think we saw one, and what were the differences in terms of what you did?
So this was the old architecture. We had like persistence layer with the Redis as a caching layer, and we have different consumer which is feeding the data into our persistence layer, which is required to power the screen. Like we follow microservice architecture, which is where like the transactional data where it has happened is somewhere else. So we are feeding that data through Kafka. And in the new architecture, if you see, like we have removed that caching layer and the persistence layer with the single Aerospike. And for high availability, we are keeping a passive Aerospike as well. And that is why we are using XDR.
Hello.
Yeah. Oh, yeah.
So, good presentation, guys. What is the use case for linearized lead? Is it because you don't want to send all the reads directly to the database for scalability?
No, because like every team edit or every team creation, like that guy has to, whenever he creates a team, that guy has to always see his edit. Like in fantasy gaming, there are a lot of users actually misuse, or there are a lot of mobile applications or apps from which he wants to create a team, and that may sometimes create inconsistency of data. So we went with the strictest possible consistency here. That is the linearized read what we have used.
Okay, thank you.
Yeah. So my question here. Hi. Could you please describe and tell what was the effort in the change, like from RDS to Aerospike in the code at the code level?
So at the code level, yeah, like there is an effort, like we are changing the client, but since like we already had the operational experience and like how to use the client in the best possible way with the Aerospike earlier, because we started using Aerospike since 2018. So the effort was maximum a month for us to migrate the entire service from the existing RDS Aurora and the caching to Aerospike.
And how about the migration from the RDS to Aerospike?
So that was like a one-time backfill that we did using Aerospike, and that's the same Aerospike code we are using on a daily basis to migrate the static data into Aerospike, and we use the same script to do the backfill as well, which was like for the whatever time period for which we want to show the data.
So we have a copy of data on S3.
Yeah.
So like that S3 data is in RDS also, and then that again we can copy it back to Aerospike. Like this is how we refilled Aerospike out here.
Thank you.
So it was not through the getting the data from RDS Aurora and putting into Aerospike, it was through S3 only, because we keep all our data on S3.
On S3. Okay. Thank you.
Hey, it was a great presentation. I have a question. There's one slide where you are copying the data from Kafka to Aerospike and across the data centers also.
Sorry?
Across the data centers, there are two different Kafka instances that you are running, and then you are copying the data directly into the Aerospike.
Yes.
So just wanted to know, instead of moving away from XDR and moving into the Kafka directly into ingestion process, is there any specific
So we
reasons?
wanted like the fast, the minimum downtime, and that is where, like, if anything happens with the active Aerospike, we want to switch our traffic to the passive Aerospike. So that was the strategy.
Okay, but
Did I answer your question?
No, but any specific
Can
reason?
you please be a bit louder?
Okay, any specific reason for moving away from the XDR to Kafka? This is
Moving from
Yeah,
You're
there's
saying
one
from
slide.
Kaf.
Maybe in the next slides.
Okay, he's talking about team service.
Okay.
Yeah.
So
one.
this architecture, right? Yeah. So of course, like we thought of syncing Aerospike active to passive, like using XDR. But then we we always wanted a one-click switch. Okay. And whenever you do a one-click switch, there will be some records in transit because of, let's say, network, some network delays there, or some cases but there will be always a delay. And you cannot just overwrite the record. So you need so we actually wanted some custom implementation in case we want to switch from active to passive. So let's say a user writes to active, and also and there is a cluster switch and people also write to passive. The handling or the merging of the teams, this logic was explicit, and that is why we wrote our own consumer and we had this logic to implement there. Because XDR would ideally just override it, or you have to handle it explicitly. But here we can write our own logic how we want to merge the teams. Because once you do a one-click switch, like someone must be writing to active also, and the other guy, like after the switch, that guy can still write to passive once the switch happens. So then there can be a conflict, and to handle that conflict, we basically wrote our own consumers to handle this conflict. So this is more kind of a business way how we handle the conflicts. That is why we had to go with a consumer.
Thank you.
So one question is, how often do you upgrade this team service? Like every week or monthly releases? And how do you make sure the uptime is whatever, I think 99, I think whatever you're targeting?
So you are saying about the architecture, how?
No, how do you upgrade like new features, new releases? How often do you do it? And how do you make sure your uptime is higher right now? Any idea?
Depends on what kind of features we have. Like if these are business features, like they come pretty like every 3 months or a quarter. So features is mostly based on the application. The whole data structure what we have used in Aerospike, that is not changing. That is like constant, and that is significant, and that is robust. Like we have done a lot of chaos testing to ensure it is robust. We have always made sure we have always done fire drills from moving from active to passive. We have done fire drills to simulate split brains and taking nodes down. This is how we have ensured that we are okay in case of there are any disaster scenarios.
Yeah, got it. Thanks.